Hi, today we are working on changing state, and we're going to specifically look at melting ice cubes. So you can see we've actually got a few experiments set up here. We're going to melt ice cubes at room temperature on hot toast, in our hands, and with hot water. You want to make sure you are all set up and have 4 ice cubes ready to go if you're doing 4 experiments like us. So the toast has been toasted, the timer's ready to go. I've got some helpers here. An ice cube with room temperature air, an ice cube on toast, an ice cube in hands, and then some hot water ready to go poured on top of that ice. So we're going to give each of these ice cubes 5 minutes and see if there's any difference in how fast they melt. Remember, melting, you're putting energy into your substance, so the particles are moving faster and faster and turning from solid into liquid. So control, we didn't change anything. Some hot toast, some hands. You can see that ice cube is already shrinking, and these ice cubes were approximately the same size. In the hot water there, the ice cube is almost gone. We're about a minute in, and you can see the steam coming off. That's water vapor, and the ice cube is almost completely melted. Hands, hot toast again, room temperature. Some of the timing has been sped up, so this is about a minute and a half in here. And you might think about, is the air giving a lot of heat to the water? Is the toast giving a lot of heat to the water? Are the hands giving a lot of heat to the water? And then you can see there's not even an ice cube left in that hot water there. So time's continuing. You can see some melting, some liquid water showing up there. It's hard to see it on the toast. Ice cube is getting small in the hands. Just about done here. So you want to make sure that you write down observations about what you see here, or even better, hopefully you're doing this in your own kitchen with whatever equipment you have around. So we're moving each of those ice cubes to a separate plate to be able to see the differences. We have hardly any change from that room temperature air. A little bit of change in size from that toast. Very little ice left from the hands, and then the hot water has completely melted it. So just a final look here. And then in a second, we'll look at an animation of what was happening at a particle level as melting occurred. What we're looking at here is solid ice, solid water, and you can see that there's some hexagons here. If you look at snowflakes up close, they're always in a hexagon sort of shape. So I've got these molecules of water that are moving a little bit, but they're stuck in place, and there's actually a lot of space in between them. This means this solid is actually not super dense. Now, as I heat this up, like you did in this lab experiment, we're going to see some changes. So I'm adding some heat. You maybe added this in some different ways, but as I added heat, you can see the temperature increased. Notice what happened to the particles, or the molecules. They're moving a lot faster now. They're not frozen in place, and they are still stuck together, still attracted, but they're not frozen like they were before. So what we just saw happen was melting as I added that liquid. If I continued to heat this, then those particles start to move faster and faster. I'm adding energy, and I'm seeing that added as kinetic energy, energy of movement. So as I continue adding energy, the molecules start to move faster and faster, and they're actually escaping as a gas. So eventually, once this is hot enough, these particles are moving very fast. This is evaporation or vaporization, 2 different words you could use, where now my gas is filling up the entire container. Now, although we didn't do it in this experiment, we did it in the last piece. If I cool this back down again, then I'm removing energy, so pulling out that kinetic energy. As I've cooled it, you can see that these molecules are moving slower. So this is condensation, when my gas becomes a liquid. If I can continue to cool it, those molecules are moving even less, even slower. And all of a sudden, you notice how they kind of popped out and made some space here. So now they're not moving and they're not as dense on the bottom. So what just happened is freezing. And because they are frozen and they're water, we actually have a less dense solid in water than we do for the liquid, and that's unusual. So any substance is going to have particles that move less and stick together as you solidify. Water is unique in that when it freezes, you actually get these pockets of air trapped inside, and so water as a solid is less dense than water as a liquid. And you can see that when you see ice cubes floating. So that's just a little unique property of water that's actually really helpful and explains why icebergs float and ice cubes float. And now you can see the molecules.